Now, there's a third effort that I alluded to. The question is there any life elsewhere? Now, to be sure, if the Starshot probe flies by a planet in one of the nearby star systems, it can detect, or should be able to detect, evidence of life. But there's a key question: can we do this remotely? So we announced in January of January 9th of 2017 in Santiago, Chile, Breakthrough Watch, which is an effort to find out, is there any evidence of life in nearby star systems or even our own star system? Now, most people have said the first place we should look for life is Mars. Mars has strong evidence of having, at one time, an environment sort of like the early Earth, with oceans and a fairly heavy atmosphere that could have allowed for the emergence of life. There's been a lot of efforts, no life found to date, but I think there will be in the future. In particular, we need to dig below the surface to get into areas where we think there's liquid water, which is one of the necessities for life. So the foundation, our foundation, is, although very interested in this question, we're not planning to study Mars. Now, there are other places in our solar system that look very, very interesting. It turns out in the last few years, based on space probes, we now know that many of the moons, the objects orbiting some of the outer planets, actually have oceans. So one of the key things you need for life, we think, is a fluid, probably water. Initially we thought, well, the only place you'd find water would be an ocean like on Earth or early Mars, but now we're finding that these moons of the outer planets have water. They also have a source of energy in the case of one of the moons or several of the moons of Jupiter, but most importantly, the moon Europa, that the gravitational compression and expansion caused by Jupiter itself will heat this ocean. So Europa has a rocky core, sort of like the moon. Surrounding it is an ocean of water, and then on top of that is ice. So the question is that can there be life? There is energy sources, and we think maybe primitive carbon compounds in that ocean. So there's a lot of effort of going to Europa. But Europa is deep in the gravity well of Jupiter. It's a high radiation environment, very expensive set of missions, and we're pleased to see that NASA and other space agencies are working on that. So again, we've sort of dismissed Europa. But there is another moon, one of the inner moons of Saturn. It's a very small moon, only a few hundred kilometers in diameter, called Enceladus. And it also has an ocean and ice, but the interesting thing is the Cassini mission to Saturn, which just in September ended its mission, discovered that on the south pole of Enceladus there are geysers of water that are spraying into space. The Cassini mission also discovered that these geysers contain simple organic molecules as well as atomic hydrogen, which indicates an energy source. So Enceladus, many people believe, is the most likely place in our solar system outside the Earth to look for life. And it's convenient because the water is accessible. We don't have to drill through the ice to get to it. So one of the things that the Breakthrough Prize Foundation is beginning to look at is, are there potential that we could work with others to do private missions to Enceladus? So that's one of the areas that we're very interested in. But the most interesting place, I think, to me is outside our solar system, are the nearby star systems. So we have made our Starshot target to be the Alpha Centauri system, 4.3 light years away. Alpha Centauri is an interesting system. It actually has 3 stars in it, whereas in our system there's just 1 star. But 2 of the stars are like the sun. One's a little bigger, Alpha Centauri A. Alpha Centauri B is a little smaller. These stars orbit each other every 70 years. We think that a planet like the Earth could exist orbiting either one of them. So that makes it a very interesting potential target, but as of today, we don't know whether there's any planets around them. The third star in the system is called Proxima Centauri. It orbits very great distance from the other two. Thousands of astronomical units, where an astronomical unit is the distance between the Earth and the Sun. And it's a red dwarf star. It's one of these little tiny stars, although I might add that 70% of the stars in the galaxy are red dwarf stars. We didn't really know anything about Proxima Centauri until a few months after we made our announcement. And this is sort of underscores my view, as it's often better to be lucky than good. But the European Southern Observatory near Munich in Germany announced the detection of a planet orbiting Proxima Centauri that was about the size of the Earth in the habitable zone. I was honored to be invited to the European Southern Observatory, probably because they wanted us to help them find out more information about these. But we now know at least one planet in the Alpha Centauri system, the one orbiting Proxima Centauri, that could be a life-bearing planet. So we have a target, although I will say that the European Southern Observatory already has a picture of the planet. So I guess we don't need to go there, although it's an artist's conception. So we need to go whether it really looks like these pictures or not. Now, Alpha Centauri is an interesting system. If you live in the southern hemisphere, you're probably very familiar with it. It's one of the brightest stars in the galaxy, but it's very far south. Its declination, how far south is like minus 61 degrees. So you can only see it from the southern hemisphere, which means if we want to study it or we want to go there, we need to do things in the southern hemisphere. So one of the things that we have done in the Breakthrough Watch program is we have a joint program with the European Southern Observatory to see if we can first directly detect, and the technology is getting to the point where we can directly image, particularly in the infrared region of the spectrum, at 10 microns wavelength for those that are technically inclined, planets using the existing 8-meter telescopes at the Very Large Telescope in Paranal in Chile. So we've begun this program. By 2019, we may be able to begin detecting a planet in that system. Now, there's a new generation of telescopes. These are of order 30 to 40 meters in diameter, called the Extremely Large Telescopes, or ELTs. The biggest one is the European Extremely Large Telescope, 39 meters in diameter, where the construction has just begun in Chile. I'm always amused about the names of telescopes, that you had the Very Large Telescope and now the Extremely Large Telescope. Although I'm told by those that designed this telescope, it was originally supposed to be called the Overwhelmingly Large Telescope, but they had a budget cut, so it's a little smaller. I guess the system we're going to build, which is also a telescope, the laser beamer, will be called the Awesomely Large Telescope, assuming we can do it. But at any rate, the 39-meter European ELT is big enough that not only could it detect and image a planet around the Alpha Centauri stars, it could also get a spectrum. So from this device, when it's completed, we may be able to see not just the planet, but get some preliminary indication of atmospheric constituents, perhaps oxygen, water, and maybe a few other things that would indicate life. Now, this will be a decade or more in the future, but very exciting that very soon, at least scientifically speaking, we may have evidence of a life-bearing planet nearby. We also are interested in potential space missions that could get more information about the planets in the Alpha Centauri system. We've begun a joint effort with the Italian Space Agency and the University of Sydney in Australia to develop a small spacecraft to study the Alpha Centauri system. It's called Ptolemy. It's designed to measure the distance between the two Alpha Centauri primary stars, A and B, very precisely. In fact, again, on a technical level, better than a millionth of an arcsecond. With that level, we should be able to see evidence of planets orbiting one or the other stars and actually get some information on their mass. Now, there's one last thing that the Breakthrough Prize Foundation does for our initiatives. Every year we have a conference. It's called the Breakthrough Discuss Conference. It's held at Stanford University around the April 12th, the anniversary of Yuri Gagarin's flight. I might add that Yuri Milner was named after Yuri Gagarin. Just in case I didn't believe him, I asked his mother, and she confirmed that he was named after Yuri Gagarin, who was launched a few months before Yuri Milner was born. But this is really a kind of a space milestone day, and a lot of you may know of Yuri's Night, which is a celebration. So there's a lot of cool things going on around the Yuri's Day, but one of them is the Discuss Conference. We have this every year. The most recent one was in April 2017, and we began to really discuss this Proxima b planet, as it's called, orbiting the Proxima Centauri, which actually is a little closer than the two Alpha Centauri large stars. And we looked at what could we find out about these planets, or this planet that's orbiting it, remotely from the Earth. We looked at what kind of instruments would we put on board our star chip when in a few decades we fly by. And we certainly want to do an intensive search for intelligent signals, although highly unlikely. We certainly should look. Now, I might add in intelligent signals that if you see a television show or a lecture about search for extraterrestrial intelligence, it said, well, we've been broadcasting signals for decades. One of the standard things is that the aliens could have picked up I Love Lucy, an American show from the 1950s. By the way, when we do the calculations, we find that if this show wasn't particularly beamed at you, that it was just a broadcast, that just today with these new telescopes, radio telescopes, do we have the sensitivity to pick up I Love Gork if it was broadcast from Proxima b. So it's interesting. This is called leakage, that we're just now having the ability to study that. So we certainly want to study to see if we can see non-deliberate signals sent to us. We also are very interested in working with space agencies around the world. We're very interested in what's called public-private partnerships. Indeed, along with our Breakthrough Discuss Conference in April 2017, we invited the heads of science of the world's space agencies, most of whom showed up, and we began to discuss the joint projects such as looking at the plumes of Enceladus and interstellar missions. Really, in closing, I think the key thing is that if all goes well, sometime in the first few decades of the second half of the century, maybe 2067, we hope to receive a image back of a planet orbiting our nearest neighbor, and maybe if we're really lucky, we find evidence of life. And if we're extremely lucky, there may be even evidence of intelligent life. So a very exciting program. We're on our way. I think this is the century when humanity will begin to become a galactic civilization. If the last century is where we began to be an interplanetary civilization, this is our century of interstellar studies, and we really invite all of you to come and work with us. Thank you.